Hi everyone, I hope you're doing well. We're going to continue on to our second lesson now of this little mini unit on rational expressions. And today we're going to look at some operations when you have variables in your denominator, where we're going to look at specifically multiplying and dividing rational expressions. So just remember, when you're multiplying or dividing with rational expressions, you can always think of, if you look at the top here, we can think about canceling any common factors. And we can do that both, from the numerator to the denominator, but also from any numerator to any denominator. So I say diagonally here. And you'll see what I mean in a second when we look at this. And then you can multiply. And what this does is, if you look at, for example, 4 over 3 times 15 over 8, if you wanted to, you could simply multiply the numerator times the numerator, and then separately the denominator times the denominator. The problem with that is that if you're trying to do this quickly, you're going to get big numbers, and then you've got to reduce it after. So this idea of canceling any factors. So when you look at it, I would look top to bottom. So 4 over 3, there's nothing common. And then 15 over 8, there's nothing common. But what about diagonally from 4 to 8? So 4 divided by 8. I can do that because the 4 is in the numerator and the 8's in the denominator. So this becomes 4 goes into 8 2 times, and that becomes a 1. And then I can do the same thing, only diagonally from the other two. So 3 goes into 15 5 times. So I'm left with a fraction in the beginning, my first fraction, 1 over 1, and my second fraction, 5 over 2. And so then I would multiply straight across, top times top and bottom times the bottom. So I end up with just 5 over 2. If you can do that, it's going to save you a bit of work afterwards. And in this case, you'll see when we look at some expressions here, it's going to be helpful to do that, but then sometimes it gets a bit tricky. And the first example is a perfect one to look at for that. So it says the process is the same for the rational expressions. So just like we did last class, you would first look to factor. In this example, there's nothing common to the top and bottom. There's nothing, we don't have any more terms than the top than 1, or the bottom also just has 1, so we can't factor. What we can do here before we start to divide things is to state our restrictions on the denominator only. And so remember, the denominator here, I've got 15, and then I've got an 8b squared. So b is the only one that can't be 0. And because it's 8 times b, the only thing that would make that 0 is if b was 0. So I'll state just b cannot equal 0. The squared really doesn't have any effect on that. Next, what I can do is look to divide common things. So notice there's a bunch of a's, there's some b's, and there's also these coefficients. I would start separately just looking at coefficients. So this is where you can see it's going to get a little messy pretty quickly. So if I start, I don't know, everyone's eyes are going to be pulled in different directions on this one. But like I see this 5 and the 15. So I know that 5 goes into 15 3 times. I like that because the 5 goes away completely. Next, and this is where you could do this in a whole bunch of different orders, endless number probably. I've got 12 divided by 3, so my first fraction. So that 3 goes away, and this becomes now 4. And you could have maybe said the 12 and 8, you could have got something. It's really up to you. And then now I look at the other coefficient of 8, and I have this 4, which goes into 8 2 times. And so what happened is all of my coefficients have gone away, or become 1, except for the 8 became a 2. But already when you look at this, it's hard to keep track of. And this is where you really need to focus just on the question when you're doing it, if you're going to approach it this way. So now I would look at, let's say, the a's. So I've got an a squared in the numerator, then another a in the second one. And so there are no a's in the denominator, so that's just going to become a cubed. And I already know it's going to be over 2 because that's what I reduced those coefficients to. The next part would be my b's. I've got a b times a b in the numerator, and then a b squared. And so b times b in the numerator becomes b squared. And so that divides with this b squared, and so the b's are gone. And so I end up with just a cubed over 2. So that's the correct answer, but if you wanted to approach this in a different way, so I'm just going to rewrite it. You could Simply multiply everything across the top and everything across the bottom, and it still will work. So I have, I guess it's 12a squared b over 15 times 5ab, and it's hard to see there, ab squared, or 8b squared rather. So if I did multiply it without dividing anything, and you could do a mix of these two approaches, and this is why I wanted to show it to you. It's really, each questions could be different, and it's whatever your comfort level is going to be with each. So I'm going to multiply the coefficients on top. 12 times 5 gives me 60. And then a squared times a gives me a cubed. And then b times b gives me b squared. Notice I just stuck with the coefficients, then moved to the first variable and the next variable. Then do the same thing on the bottom. This is where, again, maybe you need a calculator. 15 times 8 gives me 120. And then there's no a's, and it's just b squared. After you do that, then you could look at dividing everything. And so it's just a slightly different approach, gets you the same answer. So this goes away, and you're left with just a cubed over 2. Again, sometimes you might do a hybrid of those two approaches in order to get where you want to go. It's up to you. Okay, the next question more closely resembles to stuff that we were working on last class. And this one, we're going to try to multiply this. Before I multiply it, you really have to remember you need to factor. And if you don't, what you're going to get is really messy stuff that's going to be really hard to simplify after. So before I do anything, I'm going to factor this. I'm going to factor as much as I can, the numerators, the denominators of both fractions. So if I do that, and you can take a moment to try this, and this is great practice. This is not complex trinomials, so it's pretty straightforward. In the numerator of the first fraction, I can take a common x. So it becomes x times x minus 1. Denominator, again, you can try this out. Two numbers are multiplied to give positive 3 and add to give negative 4. I've got x minus 3 and x minus 1. And then times, you can go through and factor these guys. So this one's a bit trickier. Multiplies to give positive 6 and adds to give negative 5. That means both of these have to be negative, which is only going to work if I have negative 3 and negative 2. So a lot of people would want to put 6 and 1, but that doesn't work. And then at the bottom, a common factor of x, and that leaves x plus 4. So again, at that step, I'm going to take another line just below just to state all my restrictions, which is a lot. So I do it before I divide things. So I've got x cannot equal 3, 1. This guy is going to be 0. Just don't forget about him. And then negative 4. So I got 4 different restrictions. Then you can go into your dividing common factors. So take a second to do that. Again, you can try this if you want. Those x's are gone. This is the satisfying part. And we're left with not a whole lot, just x minus 2, I guess, over x minus, or plus 4 rather. Like that. And then you're done. So you can see it can become a much simpler equation from the original. Okay, why don't you try these two, and I'll go through them obviously, but try them out first before you check out the answer. Okay, so again, first thing I should do here, if I can, is factor. There's not a lot to factor, but you can factor. So I got 2y on top. I can factor this by taking 5 out. And that's actually the only thing I can factor. So once I do that, then I can look to the denominator to state my restrictions. Oops, this is an x, it's y this time. So I got y cannot equal, and this first one will be 1, and then the second one would be 0. Once I do that, I can start to divide what's common. Recognize that's kind of like in brackets, so that's gone. The y's are all gone, and then I'm just looking at coefficients. So I've got 2 divided by 6, so that goes into 6 3 times. So the numerator just becomes 1, I guess, and then in the denominator I've just got 5 times 3, which is 15. So in the end we have no variables and just a fraction. Next one, lots of factoring going on here. So common factor of that guy. Again, make sure you've tried this before you watch this. And then on the bottom, y minus 5 times y plus 2. And then what do we got here? Y minus 5, y minus 4. And then 4y squared. So state all my restrictions, y cannot equal 5, -2, and also 0. Oops, then we can go into dividing what's common. So this is the nice part. Looks like the y is -4, but they won't because one's both in the top. But I can get rid of this y with that squared, and then 2 goes into 4 2 times. So now I think we've got everything. And if you ever miss anything here, you can always check again after you multiply the tops with the bottoms. And so in the bottom here, we got 2y, which I'm going to write first, times y plus 2. You could write it the opposite way, but generally, if there's just a single y, we put it in front. And now I would look to see if there's anything common, if I missed anything, and it doesn't look like it, so we're good. Okay, let's move on to dividing rational expressions. So very similar to multiplication, except for one extra step. Remember, when you divide with fractions, you must first change it into multiplication, and the way to do that is to flip the second fraction. So I need to flip the second fraction. For example, if I had 4 over 9 divided by 16 over 15, this would become 4 over 9 times, and then I flip the second fraction like that, and then you can go into your process of simplifying. So 4 goes into 16 4 times, so I end up with, I guess, 15 over 9 times 4, which is 36. And if I can reduce that, I should, and so I guess I can divide everything by 3. So this becomes 5 over 12. And we're good. So that same idea is going to apply when you have variables in your rational expressions. So always still look to factors. So number one thing is to factor. So when I look at this one looks like you should be able to factor, but I guess if you scan through, lots of x's and y's, but there's no common factors. So the first thing I'm going to do is I'm going to flip the second fraction. So that becomes times, and then y over x plus 3y, and then 9x over x minus 5y. And so when I look at the restrictions, and I put the restrictions as the second step here, but really you could flip it and then look at restrictions, there are going to be a lot of restrictions here. So let's just start with the first denominator. So I've got x cannot equal 0, y cannot equal 0. Now here's something that's a bit strange. Because I flipped the second fraction, I have to take restrictions from both the numerator and the denominator because they were both in the denominator at one point. Like this part was in the denominator here, and now the numerator became the denominator. So I'm going to state new restrictions from both fractions denominator, but just from denominator and the numerator of the second fraction. So just watch out for that. And so if I do that, I've already got y equals 0, so that's that guy. This one's a bit weird, so I've got x plus 3y cannot equal 0. So x cannot equal negative 3y. And then also in the denominator here, 9 times x, so x can't be 0. And then x cannot equal, x minus 5y cannot equal 0. And rearrange that, x cannot equal 5y, like that. And so you could express that as the same thing would be 5 cannot equal x over, or y cannot equal x over 5. Both would be correct. Okay, now we've got the restrictions. Now we can look to see what's divided. Let me get rid of that check mark. So if I do that, obviously we get a common, and you can go through this yourself if you want. That's going to be gone. I've got a y squared and a y, so that y is gone. And that might be it. And so we might be able to, the 6 and 9 maybe. So this becomes 2 and that becomes 3. Again, if you miss something, you can always check again on your next step. So it looks like from the first fraction, I've got 2 on top and then times x plus 3y. And then in the denominator, I've got x times xy times 3. So I guess that's 3xy, but then it's also times an x. So I'm just going to write this one in 2 steps just so you see it. So this becomes xy times 3x because that's what's remaining from both those denominators. So then if you want, you can take an extra step and put them together. So xy times 3x becomes 3, and then my x times x becomes x squared, and then the y. And then you would always check to see if there's anything common, and it looks like we're good. Okay, next one, again, lots of factoring. So first thing I'm going to do, and if you want, you can factor while you flip it. It's up to you. I'm going to factor this numerator. So two numbers that multiply to give positive 4 but add to give negative 4. So that's going to be a minus 2 times a minus 2. And then in the bottom, watch out, this is one of those difference of squares. So I've got a minus 2 times a plus 2. And that gives me that difference of squares, a squared minus 4. Then I'm going to flip the second fraction, and I'm going to factor them. So just watch out, this denominator now becomes the numerator. So two numbers that multiply to give 6 and add to give 5. So a plus 3, a plus 2. And then the denominator, I guess that's going to be minus 3, a minus 2. Yes, like that. And then we can state our restrictions. So a cannot equal positive or negative 2 from the first denominator. And then looks like positive or negative 3 because I'm taking it from the numerator and denominator. And then those 2 and negative 2 repeat themselves. So we're good. So we got 4 different restrictions. And so now, oops, I forgot my equal sign. Now we can divide what's common. So go through your process. We got these a minus 2's are gone, a plus 2's, and it looks like we're just left with the a plus 3 over a minus 3. And we're good. Again, check, but you can't cancel anything out. So look through the U-try here, and I'll put in some answers. And if you want to, you can stop the video now or fast forward and see the answers. So I'll put them in right now. So there's my restrictions. Now we can cancel. Well, I guess I can factor my first. Maybe I'll get rid of that. I need to factor my first fraction. So I can pull out a 4x squared, which leaves x plus y. That's going to change things. Oops. Now we can divide. So I've got 2x and 4x, that becomes 2. My squared and my y, that's gone. This 2 and that 2. And then y plus, or x plus y squared gets rid of one of those. So it looks like we're just left with, in the numerator, oops, this was cubed. So we're left with x squared. So that becomes 2. So x squared y over, and the denominator, we've just got the x plus y.